In this section, we will learn probability so that we can use it in the inference step in studying statistics. The probability is how likely something is to happen, something is to occur. It means the possibility or the chance, how likely that a given event occur. It is a mathematical description of a randomness and uncertainty. When talking about probability, there is a degree of uncertainty. For example, if a couple are about to have a baby, it is uncertain whether the baby is a boy or a girl. The event that will get the gender of the baby, whether it is a boy or a girl, is random. The likelihood that the couple is having a boy or having a girl is 50-50. There's a 50-50 chance. Another example, if we were to toss a coin, the coin had two sides, head or tail. If we toss this, we are not certain whether the head or the tail side will show up. It is random. We are certain that one of the sides show up, but we do not know which side will show up. The probability of getting a head or getting a tail is therefore 50-50. If we were to roll a die, and this die has 6 faces, number 1, 2, 3, 4, 5, 6. The chance that we will roll a 1 is 1 out of 6, a 2 is 1 out of 6, a 3 is 1 out of 6, a 4 is 1 out of 6, a 5 is 1 out of 6, and a 6 is 1 out of 6, assuming that this is a fair die. This is because this fair or unbiased die has 6 phases, and each of the phases has equal likely chance of getting selected. It is lengthy to keep writing in words the probability of so and so we usually let the uppercase letters such as A to represent an event. We denote the probability by using the uppercase letter P. Then P of A represents the probability that A occurs. For example, the probability of getting a head from tossing a coin is written as P of A, where A is the event of getting a H or head from tossing a coin. Usually we use adjective letter, and so P of H represents the probability of getting a head. P of T, therefore, is the probability of getting a tail. The probability of an event tells us how likely that it occur, and it is a number between 0 and 1, including 0 and 1. If the probability is 0, then the event is impossible to occur. If the probability is 1, then the event is certain to occur. 0 is 0% and 1 is 100%. If something is certain to happen, then the probability that that event happen is 1. Again, the probability is a number between 0 and 1, including 0 and 1. If an event has a probability of 0.8, for example, then it is likely to occur, but it is not certain. If an event has a probability of 0.1, then it is very unlikely that it will occur, but it is not entirely impossible. We will compute the probability using the theoretical method and the empirical method. The theoretical method is known as the classical methods. It is in the games of chance. For example, when flipping a fair coin, then the probability is built in. It is classical. There's a 50-50% chance of getting a head or getting a tail. Rolling a die, the same thing. The probability of getting a number is 1 over 6 if there are 6 faces. If this die had 4 faces and if the die is fair, then the probability of getting one out of those 4 numbers is 1 out of 4, and so on. These values are determined by the game itself. It is built in. This is theoretical or classical method. Another way to obtain the probability is by the observational method. This is called the empirical method. Empirical methods use a series of trials that produce outcomes that cannot be predicted in advance. For example, regardless how good Muni is, we cannot determine whether the bus is on time or not. Whether the bus is on time or not is random. And we can use the empirical method to determine the probability that the bus is on time. How do we do this? Perhaps we'll take the bus 1,000 times, and we found that 415 times the bus is on time. So the probability that the bus is on time is 415 out of 1,000. And this is also known as the relative frequency. The probability of an event is the number of times that the event occurs out of the total number of repetitions. In this case, we repeatedly take the bus 1,000 times, and we found that it is on time 415 times. The law of large numbers say that as long as we repeat the number of trials many times for a very large number of times, then this relative frequency will turn to a probability in the long run. Let's consider another example of finding the probability. For example, in a classroom that has 3 freshmen, 7 sophomore, 5 junior, and 12 seniors, the probability that we will randomly pick a freshman is therefore 3, because there are 3 freshmen out of the total, and the total being 3 plus 7 plus 5 plus 12, which is 27. The number 3 over 27 can be reduced to 1 over 9. In probabilities, usually if the fraction is small, we will keep it. However, for most people, it is advantage to turn this into a decimal number so that we can clearly see that it is indeed a number between 0 and 1. And 1 over 9 is 0.111111, and so on. We usually round the probability to 4 decimal places. However, if the number of decimal places is asked in a problem, we will have to round it to that number of decimal places. For instance, if the question asks us to round it to 2 decimal places only, then we would need to round it to 2. And in this case, we will round it to 0.11.